All right, video number 2 for this set of notes. So we're on to example C here, and it says the cosine of 87 times the cosine of 93 minus the sine of 87 degrees times the sine of 93. Now, guys, this whole set of notes is based, or these examples are based on these equations, and hopefully you can see the parallel between this form and that first form right there. So see how it goes. The cosine of A, we have the cosine of 87, times the cosine of B, cosine of 93, minus the sine of A, which is the sine of 87, times the sine of B. Now, we don't know the cosine of 87 or the cosine of 93. We don't know those values. Those aren't ones that are useful to us. But knowing that it's in this form, I know that I can rewrite this form into this form. It can go both ways. So in the other one, we were kind of expanding it out. Now we're condensing it back down to the smaller form. So I identify that my A is 87 and my B is 93. So this is the same as the cosine of A plus B, or 87 degrees plus 93 degrees. Now 87 plus 93 degrees is 180 degrees. And you can either look at your unit circle, or you know that the cosine of 180 degrees is just -1. So all that mess just equals -1. All right, next up are the cofunction identities. So we kind of talked about these a while back, but the cofunction identities, sine and cosine, are cofunctions, and you can see right next to it, cosine and sine are cofunctions. These are basically saying the same thing, but you see that instead of sine we have cosine, but it's always 90 minus your angle, or you could use pi/2 minus your angle if you're in radians. But sine and cosine share that relationship. It's the same relationship between secant and cosecant. Remember, cofunctions. And tangent and cotangent share that same trait, that the tangent of 90 minus theta is equivalent to the cotangent of theta. So how are we going to use this? Well, it says find one value of theta or x that satisfies each of the following. So this says the cotangent of theta equals the tangent of 25 degrees. So I want to find which one of these equations is going to work to my advantage. So your best shot is going to be to recognize, hey, here's one that has cotangent of theta in it. Let's use that one. So the cotangent of theta is equal to the tangent of 90 degrees minus theta. Well, if you see the cotangent of theta, that matches up, tangent matches up, but 25 is actually where 90 degrees minus theta goes. So I know that 90 degrees minus theta equals 25 degrees. So as you get the hang of this, you might not have to write this step. You might be able to jump to this, but for now, it's good to show. So now you just have to solve for theta. So you could subtract 90 degrees. So 25 minus 90 degrees, we'll get negative theta equals negative 65 degrees. And of course, divide by -1, theta is positive 65 degrees. Example B, we have the sine of theta equals cosine of -30 degrees. Again, find the one that's going to be most useful to me. So I'm going to find the one that actually has sine of theta in it. So that's right here. I can write it in the opposite order. I can say sine of theta. I switch the side of the equal. So sine of theta equals cosine of 90 degrees minus theta. So sine of theta equals cosine. That all matches up, but -30 has to be equivalent to 90 degrees minus theta. So I'm going to write I can write 90 degrees minus theta is equal to -30 degrees. I would have to go ahead and subtract 90 degrees. And I get negative theta equals negative 120 degrees. So theta equals positive 120 degrees. All right, for the last one, we have cosecant of 3 pi over 4. Sorry, pause. Cosecant of 3 pi over 4 is equal to the secant of x. Again, find the one that's going to work best for you. But you have to realize that this is in radian mode. So instead of 90 degrees is pi over 2, so we're going to replace it with pi over 2. So the one with secant of x involved, we've got this one right here. So I've got the secant, let's see, I can write it in this order. I can write it in the order that it is. The cosecant of, instead of 90 degrees, pi over 2 minus theta equals the secant of theta. So actually, ours is talking about x, so I'll call it x. So it all matches up, but I see that 3 pi over 4 is in the place where pi over 2 minus x is. So in order to solve for x, I need to isolate my x. So I would subtract pi over 2 from both sides, and that leaves you with pi over 4 is equal to negative x. Again, divide by negative 1, and you get that x is equal to negative pi over 4. Now again, you could have converted to degrees if you wanted to, but I'd say that's just as easy. Just remember, if it's in radian mode, you need to use pi over 2 instead of 90. Now going back to our sum and difference identities, you're going to notice that if either, sorry, I'm going to move this out. If either angle A or angle B in the sum are difference identities, so that was the identities way up here, if either of those are quadrantal angles, then we're going to be able to write our expression in terms of a single function, either A or B. So example 3, it says, write cosine of 180 minus theta as a trig function of theta alone. So again, that's the difference one. So I'm going to be using this identity right here. It's the cosine of A minus B. So this is going to be equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. So the cosine of 180, if you're looking at your unit circle, that's negative 1. The cosine of theta, we don't know that. That's just the cosine of theta. So I have negative 1 cosine of theta plus the sine of 180 degrees is 0. So I have 0 times the sine of theta. Well, 0 times anything is 0. So really, this is just negative 1 times the cosine of theta, or negative cosine of theta. So you'll see that now this is just a trig function of theta alone. That's all this is. All right, so that's all for this video. We're going to have another video.